Exercise 12 deals with another interesting property of diagonal matrices, and that is that for two diagonal matrices, standard matrix multiplication is the same thing as Hadamard multiplication. So you know that standard matrix multiplication is a series of dot products. Hadamard multiplication is just the element-wise multiplication. So it turns out that those two operations are identical when you are working with diagonal matrices. So here I ask you to figure out why this is using paper and pencil. I'm not going to, actually, I don't even have paper and pencil with me right now. But I will briefly explain it, and then I will illustrate it in code. So here I create two diagonal matrices using numpy.diag, and I input just 5 random numbers. So this is a 5 by 5 diagonal matrix. This is a different 5 by 5 diagonal matrix. Here I perform Hadamard multiplication using the asterisk character, and here I perform standard matrix multiplication using the @ symbol. So two very, very different ways of multiplying matrices, and here we are going to discover that the two of them are identical. So we subtract one from the other, and we get exactly the same thing. And that's not because they're both zeros. We can see Hadamard. It's not a zeros matrix, it is a diagonal matrix. Okay, now why is this actually the case? Well, it's not really that mysterious. It's, oops, I meant to write out D2. It's not really that mysterious. It's basically just that there's so many zeros in a diagonal matrix that when you perform standard matrix multiplication, as you do the element-wise dot products, basically all of the elements end up being 0, except for the corresponding diagonal elements. All the other elements are 0. And so the dot product is just, you're just multiplying and summing lots and lots of zeros, except for the elements that happen to match, which are the diagonal elements. So that's the answer. That's the reason why Hadamard multiplication and standard matrix multiplication are the same operation, or at least have the same outcome for diagonal matrices.